Hi guys, I'm Anand Chaudhary, a rising sophomore in Monte Vista High School, and today I want to talk about derivatives of trigonometric functions. But before I get on into it, these are 6 formulas which you guys have to memorize if you guys want to be able to take derivatives of trig functions. So I'll go over them right now, but remember you guys have to memorize them if you guys want to be able to take these derivatives. First one, the derivative of sine x is equal to cos x. The second one, the derivative of cos x is equal to negative sine x. The negative is very important there. The derivative of tan x is equal to secant squared x. The derivative of secant x is equal to tan x times secant x. The derivative of cotangent x is equal to negative cosecant squared of x. And the derivative of cosecant x is equal to negative cot x times secant x. So with these formulas in mind, I'll keep them here so you guys can spend your time throughout this video memorizing them. I'm going to actually solve a few problems. First one being y is equal to x sine of 2x. So we're going to take the derivative of this. So dy dx is equal to d dx of x sine of 2x. Now, seeing this already, you know you're going to have to use some product rule with this. So dy dx is equal to the derivative, it will be the derivative of x times sine of 2x plus the derivative of sine 2x times x. So if we completely simplify this now, dy dx is equal to, this would be 1, so this first part would be sine of 2x plus, now here comes the part which we want to focus on, the sine of 2x. What's the derivative of sine? It's cos x. So it would be cos 2x. But inside is not a single variable x. So what we're going to have to do is we're going to have to apply some chain rule here. So the derivative of sine 2x would be cos 2x. But we have to apply chain rule and multiply by the derivative of 2x, which I can safely say is 2 just because of the product rule inside of there. So 2 times x outside, because that x is already there. So dy dx is equal to sine of 2x plus 2x cos of 2x. And that is the derivative for problem number 1. Y is equal to x sine x. X sine of 2x. Now we're going to move on to a little bit more complicated problem. And the main thing about these trigonometric problems is that you have to know these formulas by heart and be able to plug in the values whenever you're given, because otherwise these are just normal derivatives. So number 2, y is equal to tan squared of sine x. Now I know this looks very complicated, but when it comes down to it, if you look at it, it's just a little bit of chain rule, because there's a function inside of another function. So if we're going to take dy dx of tan squared of sine x, we have to take the derivative of tan squared. So tan is secant squared. Well, first we're going to have to incorporate the power rule. So dy dx would equal to 2 tan of sine x, 2 tan of sine x. So we're going to multiply this value by the derivative of tan x. So the derivative of tan x is secant squared x. So we're going to have to multiply it by secant squared, but not of x, of sine x. Of sine x. And then we have to multiply by the derivative of sine x can multiply by the derivative of sine x, which is cos x. And then we just gotta simplify this down. So dy dx is equal to 2 tan of sine x secant squared x. Secant squared not of x, sine x times cos x. And that is what the derivative of the second problem is going to equal to. So I hope this kind of helped you understand, but remember, this is nothing except memorizing the formulas and being able to plug it into here. These are the formulas. Memorize these by heart if you want to be able to be quick and efficient at these derivative problems having to do with trigonometric functions. Other than that, it's just following the steps of taking the derivatives. I hope you guys enjoyed the video. Thank you guys for watching, and subscribe if you haven't already. Thank you.